Hi everyone! In the previous video, we went over arithmetic sequences. This time, we will cover arithmetic series, which sums up all of the elements in a finite arithmetic sequence. So here's a question. Try to add up all of the terms in this series. Go ahead and pause the video and try to solve this on your own. If you look at it, you can realize that there's a common base number in every element in the list. You can easily add up 200 times the number of elements in the series, but then you would still have to find the sum of the series 0 plus 2 plus 4 all the way up to 50. That's one way to approach this problem, but I'll show you a 4-step method on how to tackle a generic series problem. The first thing that you have to realize is that you can add up a certain 2 elements in the list and it will give you the same sum as another specific pair in the list. Take a look. If you add up the first and last element, 200 and 250, you get 450. Now take the second element and the second to last element. 202 is 2 higher than the previous element, 200, but 248 is 2 lower than the last element, 250. So if you add up 202 and 248, you also get 250. So we can easily pair specific elements in the list to get a consistent sum, and then adding up the series becomes a lot easier. Here's the 4-step method. First, find the first and last terms in the series, then add up those 2 numbers. Third, you then have to find out how many elements are in the entire sequence, and then determine how many pairs there are. Okay, let's go through this. Our first and second steps are finding the first and last terms and then adding them together. Notice how each of these pairs here adds up to the same number, 450. We were able to cut our work in half by grouping these terms in pairs. Now for the slightly harder part of the method, is figuring out how many elements we have and thus how many pairs we have. Think about it. How many elements are in this sequence? You could list them out, going from 200 to 208, that's 5. We have 5 sets of those to get to 248, plus the last one makes 26 elements. But a more logical approach to this is to realize that you can just subtract the last and the first numbers to get its range. But the sequence contains only even numbers, so every other number from 200 to 250, so you can just divide that in half. However, when you subtract 2 numbers, you are including the top number, but excluding the bottom number. So if you want to include both sides, you have to add 1 overall. In this case, we have 250 minus 200, which gives us 50, divided by 2 is 25 elements to account for every other element. But we didn't include one of the edges here, so we have to add 1 back in. All right, so we have 26 elements in this list. That means there are 13 pairs of 450. Now our problem becomes super easy. That means our total sum of this series is 13 times 450 to get a total of 5,850. Another way to formalize this is by saying add up all of the elements from n equals 1 to 26, and in each element there's a base of 200 plus an increment of 2 times n minus 1. And that extra 2 times n minus 1 is the extra addition from the base of 200. Okay, so I have some example problems here that we will go over together. The first example is the first 4 terms in a sequence are -6, -20, -34, and -48, and the last term is -118. Find the number of elements in the sequence, then find the sum of the series. All right, let's start with the first part of this, find the number of elements in the sequence. The sequence starts at -6 and it ends at -118. However, there is a certain constant distance between each of the elements. You can quite easily figure this out. It's -14 by just looking at any 2 consecutive elements. So as we increment the element number in the sequence, the term actually decreases by 14. Okay, you might remember this formula from the last video. If we start at -6 and end at -118, and we know the spacing between 2 consecutive elements, we can find out what element number -118 is in the sequence. So let's plug in our three variables, solve for n, and find out that negative 118 is the 9th element in the sequence. Another more intuitive way to figure this out is to find the range between the first and last element. Subtract negative 6 from negative 118 to find a range of negative 112. The negative sign here in the range doesn't really matter. Just remember that we're trying to find the element number. All right, we have a range, but we didn't increment each element by 1. Our distance here is negative 14. So dividing negative 112 by negative 14 is 8. However, in this calculation, we didn't include one of the edge elements. So we have to add 1 back in to get a total of 9 elements in the list. If you struggle to follow along with the logic of +1, think of a calendar. Pick any of the weeks here that have a full 7 days. I'll look at the middle one, July 12th to July 18th. If you subtract 12 from 18, you get 6, but we know that there are 7 days in a week. And if you count actually from 12 to 18, you get 7, not 6. That's because when you subtracted 12 from 18, you took out the first 12 days from the 18 days. But we want to include the 12th day here. So we add back 1 to include the number 12. Okay, moving on. The second part is to find the sum of the series. Let's go through the 4-step method. Find the first and last terms. We got that. That's negative 6 and negative 118. Find the sum of the first and last term. That's negative 124. Third, find the number of elements in the sequence. We just found that. That's 9. And then find out how many pairs there are. That would be 4.5. 4.5 just means our list contains an odd number of elements, so there are 4 full pairs, and then the middle term or the median has no pair. So you know exactly what to do from here. 4.5 pairs times negative 124 is negative 558, which is the sum of this particular series. All right, example number 2. How many multiples of 9 are from 140 to 950? Then find the sum of that sequence. Pause the video here and try to see if you can solve this problem on your own. All right, let's start by tackling the first part. How many multiples of 9 are from 140 to 950? Certainly, it would be a mistake to try to attempt to start listing out multiples of 9. So let's use the techniques that we already know. First, let's find the first and last element in the list. The first multiple of 9 from 140 is 144. Obviously, we know 144 is divisible by 12, and both 12s here are divisible by 3, so 144 is also divisible by 9. From 950, the closest element here that's divisible by 9 is 945. Okay, dividing 144 by 9 gives us 16. So with a spacing of 9, that means 144 is the 16th element in the list if you started from 0. Okay, the same process with 945, it would be the 105th element in the list if you started from 0 with an increment of 9. Easy from here, subtracting 16 from 105 gives us 89, but add 1 back in to account for the edge term, so that's 90 elements from 144 to 945 that are multiples of 9. Okay, the second question, find the sum of the series. We completed step 1, find the first and last terms, 144 and 945. Step 2 is find the sum of the first and last terms, that's 1089. Then find the number of elements and the number of pairs. We saw previously that there are 90 elements from 140 to 950 that are multiples of 9. That means that there are 45 pairs here. Finally, multiply the number of pairs by the sum. That's 45 times 1089 to give us our final answer of 49,005. Great! Thanks for sticking with me in this video on the general techniques of how to solve arithmetic series. Quick shout out to UC Berkeley's PEACE Tutoring organization. You can check out their website at peace.berkeley.edu.